Hello and welcome to Basins and Beer with ESA Analytics. I'm Blue Spikes. Today I'm going to talk to you about the Permian Delaware region in West Texas and Southeast New Mexico. I'm going to be drinking a beer from Oskar Blues. It's called Mama's Little Yella Pills. This is one of my favorite beers. If you've been to Colorado, you've probably seen the Oskar Blues cafes and the beers on the shelves at the liquor store. But anyway, this is what this one looks like. It's kind of a funny name, but it's a very good beer. So if you're at home watching this, I hope you will crack a beer and drink it with me. This one is really good. I highly recommend it. All right, so to get started, I want to show you, in terms of the region, where exactly the Permian Delaware is located. So the Delaware Basin is this larger area here, and then we've broken it up into four distinct sub-regions. And so it's the Permian or Delaware on this side, you've got the Central Platform here, and you've got the Midland Basin on the east, and then we have the shelf around it. So we break this up because they're all pretty distinct geologically. There are also a lot of wells. So from a performance perspective, we get a better result, and it's also important to see these broken up just because they're very different geologically. The other thing I want to show you in this view is the rig count. So if we look at the entire country, you see this is the hot spot. So the red is where you have the most rigs drilling. And Southeast New Mexico has, these two counties have more rigs than any other counties in the country. So there's 50 here and 53 here. And then you have, 8 here, another 26 here, 19 here, one down here. So altogether, they have about 150 rigs drilling in just the Permian Delaware, which means it has more activity than any other region in the country. And that means it's obviously very important. And there's probably a lot of people out there working on it. So hopefully some of you are tuning in and you'll have some comments for me and questions, and we can sort of build off of this intro video. Now that we've identified where we're going and what the activity looks like, let's go ahead and load the basin. So we go down here, find Permian Delaware, hit apply. So there are quite a few wells here, but it will load quick. And just like that, we're ready to go. So zoom in. I tell people color by formation first. That just gives you a sense of, how the different formations are, or at least the different targets are distributed around the region. You can open your sidebar, sort this, and now you get not only a color legend, but a count, so you can see which formations are targeted more than the others. In this case, the Wolfcamp, Bone Spring, Delaware, San Andreas, Cherry Canyon, that's the order of importance in terms of what's being drilled the most. And you'll see when I switch to horizontal wells, so this is horizontals and verticals, but when I switch to horizontal wells, it's still the Wolfcamp and Bone Spring are your primary targets. Another thing I like to show is the distribution of oil versus gas. So one quick way to figure out, are they mostly targeting oil or are they mostly targeting gas? A quick way to figure that out is to load GOR. And the fact that it's all blue, or mostly blue, means that they're primarily drilling for oil down here. The colored pockets over here, this would be sort of the gas-rich area. You've got sort of gas-rich here and then gas-rich down here, but mostly they're targeting oil. I also like to show the faults. Now, I haven't showed this too much in my video presentations, but when people come in for demos, they always want to see this. So normally basins are bounded by faults, either bounded by a major change in geology or bounded by faults, or in this case, both. So on the east side, you have a lot of faulting right as you go up into the platform. On the west side, you're bounded by faults, and down in the south as well. On the north side, it's more bounded by target formation. So you have different targets out here than you do in here, and it's just because it's shallower. So you're going for shallower targets out here. I want to show you the Wolfcamp structure, because that's the primary target. So let's look at what that looks like, so you can just get a sense of where it's deepest or where it's shallowest, especially relative to the faults. So you see right here, as you're in the central eastern side part of the basin, that's where it is deepest. And then as you go up here onto the platform, everything is thrusted upwards. But this basin itself is, or the basin center is where you see the red dots. And I want to show real quick another way to look at this kind of a depth for the formations is on the aggregation layer. So I can choose aggregation, I can choose formation depths, and I can pick Wolfcamp, just like I did with the color by option. And then I can set my bending size. And so what this is going to allow me to do is show a complementary layer, which is my bends. And so we're going to have two ways of looking at the formation depth. So I'll turn off the well spots for a second. And we need the average, because you have two options with these aggregate layers. It's either cumulative or the per well. And so you see, you get the same result. So if I turn the dots back on and you zoom in, you can see the aggregate layer is giving you the average of all the wells in that square. And so if you adjust the aggregate size, each one of these, if it's set to 1, that's approximately a 1 mile square. If you set it to 2, it's approximately 2 mile square. So it's just a way to show two different types of data at the same time. And that's very useful. In this case, I'm showing depth in both cases, but the point is you can switch now. If I wanted to go back to formation here, for example, that might give you some more information, because now you can show, I've got my formation, I've got my depth, and I've got my faults. So depending on what you're trying to look at, this just gives you a lot of different options to utilize different layers. So I'll go ahead and turn the bending off and the faulting. Now I'm also going to filter down to horizontal wells only, because I want to look at spacing, and I want to look specifically how spacing has changed in this region over time, because this is a really heavy focus for operators, is to understand what is the ideal spacing. And we're not going to get into sort of drilling down that deep today, but I do want to show you kind of how you might do that, or at least how you might start to do that. So I'm going to choose vintage for color by, I'm going to choose oil 1 year for my size by. In my side charts, I'm going to do vintage here, I'm going to do oil 1 year here as well. I'm going to do well density on this graph. And then the last thing I'm going to do is normalize by length. Okay, so that's a lot to do all at once, but it's worth it. If you know where you're going and you know what you're doing, you might as well do all of it at once, because it's just going to be ultimately quicker. So what I've done is I've now filtered down to only horizontal wells. I'm looking at production now normalized by foot, and by looking at vintage here, so I can see how things have changed over time. So let me sort of draw this up a little bit. If I can expand that, you can get a sense that really everything was increasing in terms of well density all the way to here, and then it started to drop. And then here we want to sort, well, actually, I'll do that. I guess it was sorted already. So this is going to tell you how things have changed over time. So we have vintage here, we have oil 1 year, and it's normalized by foot. So the colors here, the more recent wells are in red, The older wells are in blue. There aren't too many of those that are visible. I mean, they're kind of in the background. They get covered up by these other wells that, where there's more red, there's more green. It tends to cover up these blues. But you can also see there are just fewer of them in general. And the numbers increased all the way till about 2019, and then they started to drop. And so if you're interested in looking at any of these parameters, this tool lets you drill down very quickly and get to the answers you need. Oh, you know what? Oh, that's better. Actually, I forgot to hit the average. So this is very important. There's cumulative and average. I thought that graph looked a little strange, but by switching to average, I'm looking at what is the average well density for each well. So that's just a little bit more important view. So you can see it was increasing all the way up to about 2022, and then it dropped. Yeah, sorry, sometimes I forget to hit those average buttons. For some variables, like oil production, maybe you want the cumulative. For others, it really only makes sense to look at it by the average, and you have to be careful to select which one. We kind of leave that up to the user. But anyway, if you're interested in these types of changes over time or production, in a specific region, you could select the wells you want or filter down to just those wells. If you just want to look at your wells or you just want to look at a specific competitor, it's easy to filter down to that, and it's just this quick to work with this application. And again, I do these videos in one cut. I'm not breaking it up. I'm not doing any editing, so you can just get a real sense of how long it takes and how useful and quick and sort of the broad application that you can apply this software to. If you haven't already signed up for a subscription, it's only $100 a month. If you compare that to some of our bigger competitors, they're going to charge you, up to $100,000 a year or more. So for this type of access to this type of data, no matter who you are, you can jump in here and start using it. Whether you're a geology professional or an engineer, or if you are a media person who just wants to understand, if you're a landman, whoever you might be, maybe you own land and you just want to know how your land compares, your mineral rights might compare to everyone around you. This application works, I think, for just a broad spectrum of people. So I hope you'll jump in here and give it a try. If you have any questions, you can always contact me. Just go to earthscienceagency.com and you can sign up for a free trial. So we have a free 72-hour trial, so you can use it as much as you want. And then if you have questions, give me a call. The number's on the website. So that's all I'll say for today. Until next time, cheers.